Programming skills using C, lecture number 13B, arrays binary search. In the last lecture, we have learned the linear search method. That is, we input some numbers, not in any particular order, and then search for a given number starting from the first number till the end of the list. Today, we will learn the binary search method to find out whether a given number is present in the list. Then also we will work out one more problem, finding out the sum of digits of a multi-digit number. The third problem is about Armstrong numbers, that is, find out whether a given number is an Armstrong number, or list all the Armstrong numbers in a range of numbers starting from 1 till the range given by us. Let us start with the binary search. Now, as you see, there are 9 numbers are there, and these are arranged in a particular order in the ascending order. That is one essential condition in the case of binary search. For doing binary search, the numbers or data should be in a particular order, in the ascending order. And then we start searching for the particular number. So how are we going to do that? So in this case, what we do, we have indices, the low index and the high index of numbers. So high index represents the numbers present in the list. And what we do every time is find out the middle index, low plus high divided by 2. For example, I want to search for 16. So what I'll do is I will 9 plus 1 divided by 2 gives me middle index 5, and I ask, is a of 5 is equal to 16? Yes, in this case, therefore we have found. In the first move itself, I have found 16. Therefore, I say I have found the number. Let us take this number 5. As you see, 5 is less than 16. Therefore, my low index remains as such. The high index is going to be 5. 5 plus 1 is equal to 6. 6 divided by 2 is equal to 3. And again, I'm going to ask, is a of 3 is equal to 5? Yes. So I have found the number. So this is the algorithm we are going to do. We are going to have two indices, low and the high. We find the middle index, and every time we are going to ask this question, if a of middle is equal to number, if it is so, then I say found is equal to 1. We start the whole search saying that found is not there, minus 1, and then we say found is equal to 1. I come out of the loop, break the loop, and then say found is equal to 1. I'm going to list that number and say it is found in the list. Let us start with again. See this chart, there are numbers, 9 numbers are there. So I want to search for 16 in the list. So low is equal to 1, high is equal to 9, middle is equal to 5. Therefore, I find out the middle. So middle is low plus 1 plus 9 divided by 2. It is a 5. Therefore, I'm asking if a of 5 is equal to number 16. Here, a of 5 is 16. Therefore, found is equal to 1. I break the loop, come out, and then list the number saying that it is present in the list. We'll take the next number, 4. So I have to start from the beginning. So starts from the beginning. As you see, low plus high is equal to 10. 10 divided by 2 is equal to 5. My first question is therefore 5. Is a of 5 equal to number? Number I am searching is 4, but a of 5, as you see, is 16. It is not so. Then I ask the question again. Is number less than a of 5? Yes, it is less than a of 5. It is, as you see, it is 4 somewhere here. Therefore, what low remains low, but high becomes middle minus 1. As you see here, in this case, high becomes middle, minus 5 minus 1 becomes 4. Again, I add 1 plus 5 is equal to 1 divided by 2. Middle becomes 2. Again, I'm asking the same question. Is a of 2 equal to number? A of 2 equal to 4. Therefore, I've come to the end of search. I come out of the thing. I list that, say that 4 is present. Let us take the third example. I'm searching for 25. Again, we start from the beginning. 9 plus 1, 10. A of 5, is it equal to number? A of 5 is equal to 16. It is not the number. Therefore, now what happens is 5 low becomes, as you see here, in this case, number is greater than a mid. Therefore, low becomes middle plus 1. So low becomes 5 plus 1, 6. I find the middle again. Again, I ask this question, is a of 7 equal to 25? Yes, I have found the number. Therefore, I come out to break the loop, again list. We come to the third number, next number, 34. Again, I start from the beginning. 9 plus 1 is equal to 10. Divided by 2 gives me, again, a of 5. Is it equal to number? No. Then, as you see, the middle becomes, low becomes middle plus 1, 5. 5 becomes 6. Again, middle is equal to 7. Again, I ask the same question. Is a 7 become is equal to 30, 34? No. So again, that number is higher than a mid. Therefore, low becomes 7 plus 1, 8. Again, I ask the same question. Is a of 8 equal to 34? No. Therefore, low becomes 9 now. Again, 9 plus 9, 18. 18 divided by 2 becomes 9. I ask the question. Is a of 9 is equal to 34? Yes, I have found the number. I come out of the loop and I print the number. Now, your effort would be, say, takes 50 as the number, right? 50 here, and go to the whole process again. You have to go through the whole process, and you find that at one point, low is going to become equal to high, less than equal to, I think instead of less than, is the less than equal to high. Then you come out of the loop, and then you say it is not present. So this is what you write the complete flow chart and write C program and execute that program. Please remember, you have to enter numbers in the ascending order. If you have not entered in the ascending order, you sort them in the ascending order using bubble sort, which you have learned, and then you apply this algorithm to search for the number in the list. Yeah, I have written here. So I have not shown you the earlier. So I have displayed the numbers, get the search number, and this is the whole algorithm to find out. As long as low is less than equal to high, less than equal to high, you go on doing that, and then if it found is equal to 1, you list that number that it is present. Otherwise, you say it is not present. With that, we come to the next problem. Sum of digits of a multi-digit number. Multi-digit number. So, for example, 4,523. We want to find out the sum of all the digits. That is 5 plus 4 plus 2 plus 3 is going to be 14. How are we going to find out? So in this case, we have to get each digit every time and then add it to the previous sum. That is what we are going. How are we going to get each digit of a number? Very simple. You take the number, take modulus 10. For example, 4,523 modulus 10 will give you 3. 452 modulus 10 will give you 2. 45 modulus 10 will give you 5. For then 4 modulus 10 will give you 0. So this is how you are going to do, find out each of these numbers. So here, how to truncate the number? That is important. So 4022 523 divided by 10 will give you 450. This is called integer division. That automatically the last digit goes. And 452 divided by 10 will give you 45. 45 divided by 10 will give you 4. 4 divided by 10 will give you 0. Therefore, our algorithm will be, as long as the number is not equal to 0, I get the digit, add it to the previous sum, go on doing that as I show you in this flow chart. So input number, initialize sum is equal to 0, and your argument is as long as number is not equal to 0, or while number is not equal to 0. So you get the digit remainder, you add it to the previous sum, truncate the number, go on doing it. At one point, number is going to be 0. You come out of the loop and you print that sum. That is going to be the sum of digits of that multi-digit number. Now you write complete flowchart and write C program and test that C program for different multi-digit numbers. Here is the program I have shown you. As you see, get the number. I assign it to one more variable p because I don't want to lose this number. And then I'm going to ask as long as p is not equal to 0. While p is not equal to 0, get the digit, add it to the previous sum, truncate the number, go on doing it. And at the end, p is going to be 0. And then you come out of the loop, print that number, and then find the sum of digits of the number. That is sum. You are going to print sum. So here I've shown you its size. I've entered this number, and then this is the sum of digits of that number. With that, we come to some more problems which you have to work out. So input a multi-digit number, find the maximum digit. Very simple. We have already done in the case of arrays, finding out the maximum number in n. Same algorithm has to be used. In this, you assign 0 to max because the lowest number is going to be, digit is going to be 0, and the maximum digit is going to be 9. So therefore, then you go on asking. Every time you get the digit, you ask if this digit greater than max. If it is so, assign that to the digit. Then input multi-digit number and find the sum of even digits. So you get the digit every time, find out whether it's even. You have done it already earlier. Modulus 2. If it is even, you add that number to the previous sum. Go on. The reversing the number, you try that. And then this is an interesting problem. Input a number and find out the binary equivalent of that number. Same algorithm has to be used. In this case, it is modulus 2 has to be done. So you maybe next time, next class, I will do this. But you try it on your own. And we come to the list all the Armstrong numbers in the range 1 to 1000. Now, what is an Armstrong number? Armstrong number is that number is the sum of the cubes of each digit. For example, 153 is Armstrong number. Why? Because 1 cube plus 5 cube plus 3 cube is equal to 153. So you therefore you know already how to find each digit. So take the digit, convert it to power 3 and add it to the previous sum. Take the next digit, make the power of power 3, add it to the previous sum till you do it for all the digits, and at the end you ask is the sum is equal to the number. If it is so, you print that number, otherwise go to the next number. So this is what you will have to do. Thank you.